Hey everybody, this is Mr. Walsh, and today we're going to be looking at the assignment where we're looking at the orbital box diagrams and trying to get information from them, like the number of valence electrons, the valence shell, and the kernel electrons. So let's take a look and let's get started. So the example here, we have sodium, and this number down here in the lower left, that's the atomic number. But it's also, in this case, the number of electrons that we're dealing with. So when we put these electrons in, you can see we have 2, 4, and then we do 5, 6, 7, 8, 9, 10, and then we put the 11 one there. Okay? And so in order to determine the valence shell, we look at the big numbers. Okay? The big numbers, the number up here. And what I'm going to do is I'm going to put a line here, and then this 3 is the valence shell, and that's where the 3 comes from. And then how many electrons? Well, we look at how many electrons are actually in the valence shell, and that's going to tell us how many valence electrons there are. There's 1 electron here, so there's 1 valence electron. Now the other type of electron is kernel, and so what I know is that the total number of electrons is 11. So if one of them is a valence electron, that means the other 10 must be kernel. The other way to do this is to count how many electrons are on this side of the line. So this is the kernel on this side, and this is the valence on this side. Okay, and so we can go 2, 4, 6, 8, 10. So that's where we get 10 from. And then if we're going to do the electron configuration, then we just read this. So we go 1s, and has 2 electrons, 2s with 2 electrons, 2p with 2, 4, 6 electrons, and then 3s with 1 electron. So we have 1s2, 2s2, 2p6, 3s1. Okay, so now if we're going to do this kind of on our own, okay, so we have K19, and so we're going to fill that. And so remember, we have the rules of filling, so that's start there, and we start here, and then we continue to the 2s, and now we fill one at a time because they don't pair unless they have to. So we're going to do that, and then we're going to go and then fill like this. So that's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And so if we're going to determine the valence shell, we look at the big numbers here. Okay, we look at the numbers up here. So there's 1, 2, 3. Oh, okay. So we can see here that the valence shell is 4. And now we're going to see how many electrons there are. Okay, well, in the 4 energy level, in the 4th shell here, there's just 1 electron. The total number of electrons is 19, so I know that the kernel is 18 because 1 plus 18 is 19, or I can count over here, 2, 4, 6, 8, 10, 12, 14, 16, 18. And now if we're going to do the electron configuration, we're going to go 1s2, 2s2, 2p6, right? 6, 3s2, and then 3p6, and then 4s1. Okay, so now we lather, rinse, repeat. This is a long assignment by page, but it's not that long when you get going on doing the actual work. It's long because we have all these orbital box diagrams. Okay, so we have 3 electrons. So again, we're going to fill this. We're going to go 1, 2, 3. Okay. So the valence shell, we look for the biggest big number that has electrons in it. So I'm going to put the line here. And so the valence shell is 2. How many electrons are in it? 1. Okay. And then how many electrons are here? That's 2. And then we will write the electron configuration. We're going to start with 1s. And then there's 2 electrons. Then we have 2s. And there's 1 electron in there. Okay, so now we're getting into some larger atoms. Okay, this has 14 electrons. Okay, so we're going to go 1, 2, 3, 4. And remember, fill the p's one at a time. 1, 2, 3. So that's 7, 8, 9, 10, 11, 12, 13, 14. Okay, try to get in the habit of filling the p's, and then eventually, if you get to the d's one at a time, and then come back and fill them the second time. Okay, so now we have the biggest big number. Here's a 3, and now there's 2 things with a 3, but that's okay. The valence shell is still a 3. And now we're going to count. We're going to add up the electrons in the 3s, so there's 4 electrons. There's 2 in the s's and 2 in the p's. Then the kernel electrons, okay, remember the total is 14. There's 4 valence electrons, so that means there's 10 kernel, or again, you can count 2, 4, 6, 8, 10. Okay. Now the electron configuration, we read it here, 1s2, 2s with 2 electrons, 2p with 6, 3s with 2, and 3p with 2. So we're going to go 1s2, 2s2, 2p6, 3s2, 3p2. Okay, now nickel. Now we have 28 electrons. So again, we're going to go 1, 2, 3, 4. We're going to do the p's one at a time. That's 7, 8, 9, 10. And then after we fill them one at a time, we're going to go back and double them up. 11, 12. Now we're going to go to the p's and do the same thing. That's 15, 16, 17, 18. So now we have 10 more to go. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay. Now, whenever you have electrons in the D's, we have to be careful a little bit. Okay, so let's look at the valence shell. Again, the valence shell is over here. Notice the biggest big number is a 4. Okay, and the number of valence electrons in this case is only the number of electrons in the 4th energy level. Notice that the D's that are part of the 3, that's the 3, so that doesn't count. We don't count those as part of the valence. So the valence electron here is 2. And now we're going to count the kernel, which should be the rest of the electrons. We get 26. Remember, there's 28 total. So let's count just to make sure. 2, 4, 6, 8, 10, 12, 14, 16, 18. Then we also have to come over here to the 3Ds, 20, 22, 24, 25, 26. 26 electrons. Okay, so now kind of the most straightforward part of this is writing the electron configuration, because you just have to kind of write what you see. 1s with 2 electrons, 2s with 2 electrons, 2p with 6, 3s2, 3p6, 4s2, 3d, be careful, this is a 3, okay, 3d8. Okay, so now chlorine here, 17 electrons, so we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 17. Okay. I got carried away. Okay, the valence shell is the 3. Count how many electrons are in the 3s. We get 7, 2, 4, 6, 7. How many are left over? 10, right? 10 here. And then the electron configuration, we're going to go 1s2, 2s2, 2p6, 3s2, 3p5. Okay, now chromium is 24. That's going to be just like nickel. Okay, nickel, we did this. It's not going to be just like it, but it's going to be very, very similar. Okay, so we're going to put 24. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so that's wild. So now the valence shell, we have D's, so be careful. So let's see, the valence shell is 4, valence electron is 2, because the four S's are kind of all by themselves. Okay, now the rest, if we count, we'll get up to 22 here. Okay, but we can count them. We have 2, 4, plus 6 is 10, 12, 14, 16, 18, 21, 20, 19, 20, 21, 22. Okay, now the electron configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. Okay, and then the last page, we'll do this up and it'll be good. Okay, so we'll go a little quicker. 36 electrons, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Whew. Okay, so the valence shell, again, is the biggest big number, so that's going to be the 4s. Okay, be careful because there's D's. Remember, the D's are part of the kernel. So 4, that's going to be 2, 4, 6, 8 valence electrons. And then the rest of the 36 are kernel electrons, so that's going to be 28. Okay, and if we count 2, 4, 10, 12, 18, 20, 22, 24, 26, 28. Then the electron configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Okay, so selenium now is going to be very similar to krypton. Okay, because it has the same sort of number of electrons. Okay, so I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. Okay? The valence shell is going to be very similar. It's going to be, right, same idea. Okay? Valence electrons now, remember that these 3 Ds count as part of the 3s, so if we look, we only have this and this, so that's going to be 6 valence electrons. It's still going to have 28 kernel, and then the electron configuration is 1s2, 2s2. I'm going to try to make sure that this fits in the box. I got sloppy up here because it was just, I'm not trying to do it quick, but I can do it quick, so, okay, so let's see, 2p6, 3s2, 3p6, 4s2, 3d10, 4p4. I didn't write neat enough. It's still outside the box. Okay, and then the last 2. Okay, here's neon. Okay, 10 electrons. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Valence shell. There's no D, so we don't have to worry about that. So that's 2 valence electrons is 8. Kernel electrons is 2, and the electron configuration is 1s2, 2s2, 2p6. Okay, and the last one is sulfur with 16. You do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, the valence shell, again, we'll cut it off. Okay, valence shell is 3. Valence electrons are all electrons. There's no D's, so we don't have to worry about that. Okay, so we're going to add those up. We get to 6. Kernel electrons is all these other words, so that's 10. And the electron configuration is 1s2, 2s2, 2p6, 3s2, 3p4. Okay, so it was a long in terms of pages assignment, but a fairly straightforward assignment to let you know how many valence shells, or what the valence shell is, how many valence electrons, kernel electrons, writing electron configurations, and using the orbital box diagram to get there. Okay? Okay, everybody have a great day.